Part B. Same thing, we need to graph the solution set and then label the vertices. X squared plus y squared is less than or equal to 25. If both variables are being squared like that, we found out it's a circle, and the square root of 25 is 5, so that's the radius. So this is going to be the worst circle drawn, but okay, I gotta try that again. Okay, I'm starting over with this. I'm erasing, getting a better graph, need a better circle. So 5, negative 5, 5, negative 5. Okay, a little better. And it's a solid circle because it's less than or equal to. Equal to means solid. And we're either going to shade on the inside or the outside of the circle. I'm going to refer to my test point 0, 0, and plug in a 0 for both x and y. I end up with a statement 0 is less than or equal to 25. That's true. So that means I'm shading towards my test point, which, well, there goes my circle. Which was inside. So we're shading inside the circle. Now the next one, y is greater than 2. If there's no x variable, it's just y equals 2 is a horizontal line, and since it's just greater than and not greater than or equal to, it's going to be a dotted line going through 2. And greater than 2 means above. Now, as I stated earlier, x equals a number. If it's just x and no y, that's a vertical line. So it's a vertical line, and I'm drawing it as a dotted line because it's just less than and not less than or equal to. And x is less than 3 means to the left, so we're shading to the left of that. So trying to identify the solution set, we got to look for the part that has all 3 shades. It's inside the circle, to the left of the vertical line, and above the horizontal line. So looks like we have this area right here. It's above the horizontal line, it's to the left of the vertical line, and it's inside the circle. So that's the solution set. Now we've got a couple of points to identify. This one right here is on the circle and the horizontal line. Since it's on the horizontal line, which always has a y value of 2, we know the y value is going to be 2. And now it's on the circle, so I can refer to this to find the value of x. That can be x squared plus 2 squared equals 25. 2 squared is 4, so that's going to be x squared equals 21, which means that x is positive or negative square root of 21. And since it's on the left side of the y-axis, I know it's going to be the negative square root of 21. So that point there is negative square root of 21, comma 2. Now this point right there, pretty easy to find. It's the intersection of the horizontal line, which has a y value of 2, and it's also on the vertical line, which has an x value of 3. So that's just the point 3, comma 2. Now that point is on the vertical line, which has an x value of 3, and then it's on the circle. So I need to go back to my circle, which has an equation of x squared, which this time is going to be 3 squared, plus y squared equals 25. 3 squared is 9. 9 from 25 is 16. Y squared equals 16 means the y is plus or minus 4. But since it's above the x-axis, I know it's going to be positive 4. So that's the point 3 comma 4. This is from section 5.3, this next question. Partial fractions. Since we only have 2 factors in the denominator, means we're going to have 2 partial fractions, a and b. And each denominator is just going to be one of the factors. Now, the next step in the partial fraction decomposition, if you remember, is to multiply by the lowest common denominator, which is x plus 4 times 2x minus 3. If the LCD multiplies all the way to the left, then the denominators would just cancel out. So then you'd be left with negative x minus 37. Now if the LCD multiplied there to the a term, then the x plus 4s would cancel. So then a would multiply only the 2x plus 3. Rather 2x minus 3. Now if the LCD multiplied there to the b partial fraction, then the 2x minus 3s would cancel, so b would be left multiplying x plus 4. So now at this point, we're solving for two things, a and b. The way that I showed you in class was to choose convenient values. This one, for example, a convenient value there would be negative 4, because that would make 0 times b, which is 0, so then we could solve for a. So first I'm going to let x equal negative 4. So you plug a negative 4 in for all of the x's. So what that'll do here is the opposite of negative 4, which is 4. 4 minus 37 is negative 33. If you plug a negative 4 in for that one, you're going to get a negative 4 times 2, which is negative 8, minus 3 is negative 11, times a is negative 11a. And if you plug a negative 4 in there for that x, then you get negative 4 plus 4, which is 0. So b cancels. Coming back here, divide both sides by negative 11, and you get a equals 3. Now this convenient value of negative 4 came from that factor, x plus 4, so it was pretty obvious that x was going to be negative 4. This other one here for a is going to be a little less obvious. We've got to figure out what makes 2x minus 3 equal to 0 first before we get the convenient value. So if you add 3 to both sides, you get 2x equals 3. So there's my convenient value. I'm going to let x equal 3 halves. So that means the x here, there, and there, all three x's need to equal 3 halves. So in the first one, if I let this x equal negative 3 halves, I'm going to get negative 3 halves minus 37. Now if I let that x equal 3 halves, that's where the convenient value came from, so I know it's just going to cancel the a. I'm going to let that x equal 3 halves, so I'm going to get b times 3 halves plus 4. So I'm going to combine those. And it's a fraction with a denominator of 2, so I've got to have that also have a denominator of 2. So if I multiply by 2 over 2, 37 times 2 is 74. So this is going to be negative 3 minus 74 all over 2. So it's negative 77 over 2. Equal, excuse me, now over here, 3 halves plus 4 over 1. 4 over 1 is the same as 8 over 2. So 3 halves plus 8 halves is 11 halves b. Now to get b by itself, I can multiply by the reciprocal, 2 11s. Then the 2's would cancel, and the 11 halves and the 2 11s would cancel, so b equals negative 77 11ths. Or negative 7. So I know now the values of a and b. A was 3, b was negative 7, so my partial fractions, which I had the form of there, I just didn't know a and b, can now write as 3 over x plus 4, and then negative 7 over 2x minus 3. Now part b, I've got really 3 factors because x minus 2 is written twice, so I'm going to have 3 partial fractions. And since the x minus 2 is the repeated factor here, you've got to write it once, and then here you've got to write it twice, because it's repeated twice. That's the form of the partial fraction. So we do the same thing we did in the last problem, multiply both sides by the lowest common denominator. Which is x minus 1, x minus 2 squared. So multiplying there to there just means the denominator there is cancel. So you're going to be left with 4x squared. Now multiplying the lowest common denominator to the a partial fraction here, the x minus 1's would cancel. So a just multiplies x minus 2 squared. Now multiplying the LCD to the b partial fraction. So that times that. X minus 2 is going to cancel with one of those x minus 2's. So b multiplies the x minus 1 and the x minus 2. Now when the LCD multiplies there to the c partial fraction, x minus 2 squared cancels x minus 2 squared. So c is left multiplying x minus 1. So we've got 3 values to solve for, a, b, and c. Do a similar method as to the problem above, choose convenient values. So if I'm looking at this factor there, a convenient value would be 2. So I'm going to start and let x equal 2. So if x equals 2, that's going to wipe out the a, because 0 times a is 0, and then that's also going to wipe out the b there because 0 times b is 0, so I'm going to be able to solve for c. So if I plug in a 0 or a 2 for that x, That one's going to cancel, that one's going to cancel, and then a plug-in is the 2 for that x. So on the left side, I'm going to get 4 times 2 squared, which is 16. That term's gone, that term's gone. 2 minus 1 is 1. 1 times c is 1c. So c equals 16. Now if I look here, I can see another convenient value of x equals 1. So I'm going to let x equal 1. That's going to take care of that, make it 0, so b will disappear. It'll take care of that factor and let c and make c disappear, so then I can solve for a. So if I let this x equal 1, I get 4 times 1 squared, which is 4. If I let that x equal 1, I get 1 minus 2, which is negative 1. Negative 1 squared is 1. 1 times a is a. And then if that x is 1, then b's gone. If that x is 1, then c's gone. So then I just get a equals 4. So the problem now is I'm out of convenient values. I let x equal 1. I let x equal 2. There isn't another convenient value to choose from any of those factors, so I need to choose just a random value for x. Like, let x equal 0, but that's not going to cancel any one of those a, b, or c. So what I need to do is plug in those values that I now know. So I'm going to let not just x equals 0, but I'm also going to let a equal 4, and I'm going to let c equal 16. I'm going to plug in all three of those values. So if x equals 0 here on the far left, I'm going to get 4 times 0 squared, which is 0. Now if a equals 4 and x equals 0, I'm going to end up with 0 minus 2 squared, so that's 4. And then 4 times 4 is 16. So I've got 0 equals 16. Now I don't know b, but I'm going to let those x's equal 0. 0 minus 1 times 0 minus 2 is negative 1 times negative 2, which is 2, and 2 times b is positive 2b. Now here I'm going to let c equal 16 and x equals 0. 0 minus 1 is negative 1 times 16 is negative 16. So, all right, I got a little messy. That should be a 16. Now we got a 16 minus 16. So 0 equals 2b. So b equals 0. So my partial fractions are 4 over x minus 1. Now you could put 0 over x minus 2, but 0 divided by anything is 0, so you don't actually need that middle one. So 16 over x minus 2 squared. We're now into Chapter 6, Matrices and Determinants. Now this question says solve the following using Gaussian elimination or Gauss-Jordan elimination. I didn't cover Gauss-Jordan elimination, and it's not necessary. You can do the same thing using just Gaussian elimination. So if Gauss-Jordan isn't ringing a bell, it shouldn't, because it wasn't anything that I covered. Now Gaussian elimination, remember, means you set up an augmented matrix, and you need to get that reduced to row echelon form. That's the process for Gaussian elimination, augmented matrix into row echelon form. So first thing I'm going to do is create the augmented matrix from that system. Remember, the augmented matrix are just the coefficients. So the first column is going to be the coefficients of x, 1, 0, 1. The second column are the coefficients of y, 0, 1, 4. Third column are the coefficients of z, 1, 2, 0. And then the last column are those values at the end, 5, 8, and 1. Now the goal, if you remember, of Gaussian elimination to get it to row echelon form is to make the matrix change colors here. We want to have a 1 and then a 0 and then a 0 and then a 1 and a 0 and then typically a 1 there. So that's the goal of Gaussian elimination. Now we already have 1 here and a 0 here, so that just needs to be a 0 right there. So to get that number there to be a 0, I can multiply the top row by -1 and then add the top and the bottom row together. That's going to make a 0. So if I'm going to describe that, it's going to be -1 times row 1 plus 3 plus row 3 is going to equal row 3. So the whole top row is going to be multiplied by -1. So if I do that here, that's -1 plus that one would be a 0 for row 3. Now if I move here, then that entry times -1 is 0, and then 0 plus 4 is 4. Now if I move here, that entry times -1 is -1. -1 plus 0 is -1. Now if I move here, that entry times -1 is -5. -5 plus 1 is -4. So I've got 1, 0, 0. That's already a 1. This here should be a 0. That's my next task, is to get that to be a 0. So if I multiply the middle row by -4, that's going to put a -4 right there. And then if I add those two, I would get 0. So I need to describe that operation. It's going to be -4 times row 2 plus row 3. That's going to be row 3. So if I start here, -4 times 0 plus 0 is 0. If I go here, -4 times 1 plus 4 is 0. If I go there, -4 times 2 is -8, plus -1 is -9. If I go here, -4 times 8 is -32. -32 plus -4 is -36. Now that bottom row represents the equation -9z equals -36. So z equals 4. This middle row represents the equation y plus 2. And now that I know that z is 4, I can call that y times, or y plus 2 times 4 equals 8. subtract 2 times 4 is 8. Subtracted from 8 means that y equals 0. This top row represents the equation x plus, now there's no y right there because y is 0, but x plus z, or x plus 4, equals 5, which means that x equals 1. So I've got my solution, 1, 0, 4. Okay, this one's going to be the same thing. Now I need to make an augmented matrix. If I just took the coefficients of x, I'm going to have negative 2, 1, and 1. Now I'm supposed to have a 1 right there as the leading entry, and I don't. But I notice I have a 1 here and a 1 here, so what I'm actually going to do is flip-flop those top two equations. So this one is going to be my top one. So 1, negative 2, 1. And this negative 2 is going to be my top coefficient for y. And then this 1 right there for z is going to be my top coefficient. And then this 3 is going to be on top. So I've got the 1 there. I need this to be a 0. So if I were to multiply the top row by positive 2, and then add those together, that's going to give me the 0. So I need to describe that operation as 2 times row 1 plus row 2 equals row 2. Now I also want this entry there to be a 0. So if I multiplied now the top row by negative 1, and then added those together, that would make a 0. So that row operation would be negative 1 times row 1 plus row 3 equals row 3. So I'm going to do this top row operation first. So everything in row 1 is going to be multiplied by 2. So that entry times 2 is 2. 2 plus 1 is 3. Sorry, I'm doing this to the wrong row. Let me try that again. This row operation affects row 1 and row 2. So starting here, 2 times 1 is 2. 2 plus negative 2 is 0. Now go to here. 2 times negative 2 is negative 4. Plus 5 is 1. Now go to here. 2 times 1 is 2 plus negative 4 is negative 2. Now here, 2 times 3 is 6. 6 plus negative 4 is 2. Now I've got to follow this bottom row operation. So everything in row 1 get multiplied by negative 1 and then add it to row 3. So now moving here, 1 times negative 1 is negative 1. Plus 1 is 0. Now here, negative 2 times negative 1 is 2. 2 minus 5 is negative 3. Now here, 1 times negative 1 is negative 1 plus 9 is 8. And now here, 3 times negative 1 is negative 3 plus negative 5 is negative 8. So I've got 1, 0, 0. I've got a 1 there. So now this negative 3 should really be a 0. So if I can multiply that middle row by 3, and then add the 3 and the negative 3, that would give me a 0. So to describe that operation, it's going to be 3 times row 2 plus row 3 equals row 3. So starting to row 2, each entry is multiplied by 3. So that this entry here times 3 is 0. 0 plus 0 is 0. This entry here times 3 is 3. 3 plus negative 3 That 0 should go there. 3 plus negative 3 is 0. That entry, 3 times negative 2 is negative 6, plus 8 is 2. And then that entry, 3 times 2 is 6. 6 plus negative 8 is negative 2. Now we're to the point where we can use that bottom row. That bottom row represents the equation 2z equals negative 2. So z equals negative 1. The middle row up there represents the equation y minus 2, and then z is negative 1 equals 2. So y equals 4. The top row represents the equation x minus 2 times y plus z equals 3. So this is negative 8, and that's negative 1. That makes negative 9. X minus 9 equals 3. So x equals 12. So the solution is 12, comma 4, comma negative 1. Now I'm actually going to do problem 25 before doing problem 24. Okay. So part B, it says to solve using an inverse matrix. The directions from before said to solve using an inverse matrix. And I'll go back and explain the directions. But it said to use the inverse matrix. So I described that in section 6.3 as matrix equations. So we have to set up a matrix equation where the coefficient matrix just contains the coefficients, then a variable matrix, and then the matrix containing the points or the values negative 4 and 8. Symbolically, this was a capital A, that was a little x. And that was a little b. So we have the equation ax equals b. And remember, A represents a matrix. You can't divide by a matrix. There's no such thing. But to get rid of a matrix, you can multiply it by its inverse. So the inverse of A times A, those two are since they're inverses of each other, they cancel each other out. So you end up with your solution x equals the inverse of A times B. And this is what we need to find, is the inverse of A times B. Now we have B, that's B right there, that matrix. What we don't have is the inverse of A. So the formula for finding the inverse of a 2 by 2 matrix is 1 over AD minus BC. And then A and D switch spots. And B and C switch signs. So referring now to this matrix here, that's our A matrix. So these two terms, the -4 and the 5, those are going to switch spots. So I'm going to put the +5 here and the -4 there. And then these two terms, the -3 and the +6, they stay where they are, but they change sign. So it's going to turn into a +3 and a -6. That's what happens inside. Now underneath here in the denominator, we have to follow that, AD minus BC. So this is A times D right there, the -4 times 5, that's -20. And then B times C is -18, so it's minus -18. So that equals -20 plus 18 is -2, so this is -1/2. So there's the inverse. So now we need to show this, the inverse of A times B. So that's 1/2, rather -1/2. And there's the inverse of A. Now I've got to multiply that by B. So this entry is a combination of that row, this row, and that column. So the -4 and the 5 are going to multiply to -20. And then the 3 and the 8 are going to multiply to 24, so you add -20 and 24. This entry is a combination of that row and that column. So the -6 and the -4 multiply to 24, and the -4 and the 8 multiply to -32, so you add -32. So we get that -1/2 that was still out in front. -20 plus 24 is 4. And then 24 minus 32 is -8. Now multiply the 1/2 in there, and you get -2, 4. So the solution is the point -2, 4. Now, with so many steps, it's never a bad idea to check. If x is -2 and y is 4, then we get in the top 8 minus 12, which is -4. And down here, if that's -2 and that's +4, then we get -12 plus 20, which is 8. So that's what it means to use an inverse matrix there. So if I go back a page, using the inverse of the coefficient matrix, this one is actually easier because they've given us the inverse already. Now there is a little error here that should be 1 over -1. So we already have the inverse of the coefficient matrix. So if you remember from the last problem, the solution for x is the inverse of A times B. So this is the inverse of A, and we can form this into a matrix here. That's going to be B. So all I need to show is -1 times this matrix. The inverse was already found for us, and then we got to multiply it by that matrix there. So this entry is a combination of that row and that column. So the 9 and the -5 multiply to -45. The -7 and the -7 multiply to +49. This entry is a combination of that row and that column. So the -4 and the -5 multiply to 20, and the 3 and the -7 multiply to -21. So then we still have that -1 in front there. -45 plus 49 is 4. 20 minus 21 is -1. So then we have -4, comma +1. So the solution is the point -4, comma 1. Again, wouldn't be a bad idea to check your work. If x is -4 and y is 1, then we get -12 plus 7, which is -5. And on the bottom, if x is -4 and y is 1, we get -16 plus 9, which is -7. Now coming back over here, Kramer's rule involves determinants. So if it's two variables, then x is equal to d sub x over d, and y is equal to d sub y over d. So what we need to find are the three determinants d, d sub x, and d sub y. So d is just the determinant of the coefficients there. 2, 3, 10, -5. The determinant of a 2 by 2 is those two multiplied first to be -10, and then you subtract the other product to go in this direction, which would be 30, and that's -40. Now the d sub x determinant, since the subscript is x, the y column is going to stay the same, so it's going to stay that 10. It's the x column here that takes these values, so 11 and 6 are going to go in place there. And then you do the same method. Those two multiply first, making -55, and then subtract the other product. 6 times 10 is 60. So if you subtract those, that's -115. Now the d sub y determinant, since the subscript is y, now the 11 and the 6 are going to go in the y column. And the x column here is going to be the same as it originally was there, 2 and 3. So this determinant is going to be those two multiplied, which is 12. Subtract those multiplied, which is 33. And 12 minus 33 is -11. So then coming over here, d sub x over d is going to be -115 over -40, and d sub y is going to be -11 over -40. Now that's just going to be 11/40ths. And then if we divide both of these by 5, we're going to have an 8 and a 23. So 23/8 and 11/40ths. Now we didn't do Kramer's rule for a 3 by 3, 3 equations, 3 variables. It's the same principle though. X is d sub x over dy is d sub y over d, and z now is d sub z over d. So we need to find 4 determinants. We need d, and we'll start with those two, just d and d sub x. So d is the coefficients there. So we're going to have 1, 0, negative 1, 0, 3, 1, negative 1, 1, 0. Now to find the determinant of a 3 by 3, you take the first 2 columns and write them off to the right side. So 1, 0, negative 1, 0, 3, 1. And then crisscross from the top left to the bottom right. So that's going to be 1 times 3 times 0. The first one is 0 plus. Now the next one starting from here is 0 times 1 times negative 1. That's also 0 plus. The one starting from here is negative 1 times 0 times 1, which is 0. Now if we go the other direction, these ones going from the bottom left to the top right, these ones subtract. So starting from here, negative 1 times 3 times negative 1 is 3. So I'm going to minus 3 because you subtract. And then starting from here, 1 times negative 1 times 1 is negative 1. So I'm going to subtract negative 1, which is actually adding 1. And then starting from here, it's 0, so minus 0. So there I get negative 2. Actually, that's not it. Hold on. What? Oh, it was right here. I thought that was a negative 1. That isn't a negative 1. So I need to go back to the ones in green. Let's try this again. This product here is negative 1 times 3 times negative 1. That is 3. And since we're going in that direction, we got to subtract. This product is 1 times 1 times 1, which is 1. And since we're going in that direction, I'm going to subtract 1. And that product is 0, so I'm going to subtract 0. So I actually get negative 4. Now d sub x since it's the x column, this x column here is going to be replaced with those values. It's going to be 7, 4, and 1. And the rest of the columns stay the same. Now do the same thing. Find a determinant. So going in this direction, well, first I got to copy the first and second column. Now going in this direction, that's going to give me a 0. That direction is a 0, and that direction is plus negative 4. Now in the other direction, this is going to be a negative 3, but you're subtracting in that direction, so minus negative 3. That one's going to be a positive 7, but you subtract it, and then this one is 0. So negative 4 plus 3, which is negative 1 minus 7 equals negative 8. So I'm out of room. So I've only done 2 of them. I've got d sub x and d. Well, the process would be exactly the same to find y and z. So to find d sub y, you would replace the y column with 7, 4, and 1, and then find the determinant. To find d sub z, you replace the z column with those values, 7, 4, 1, and find the determinant. All right, last chapter that we studied was chapter 8, sequences and series. So this question here, number 26, find an expression for the nth term, a sub n. Often I refer to it as the nth term, but it's also the same thing as finding an explicit formula. Now, one key word here is that this sequence is arithmetic. What that means is linear. The nth term is a linear formula. If we look at the difference between terms 3 to 7, 7 to 11, 11 to 15, the common difference is 4. So if we're thinking linear formula, or mx plus b, the common difference is like your slope, m. So a sub n equals 4n. And then, so remember, linear y equals mx plus b. M is the common difference. B, this b right here, is like your 0 term, or your y-intercept when x equals 0. So if there were a term in front of the first term when n equals 0, it would be negative 1. So the nth term, or the explicit formula, is 4n minus 1. And it doesn't hurt to check this. Just choose a term like this one is when n equals 3. So if we were to plug a 3 in for n, you get 4 times 3 minus 1, which is 11. Now the 100th term, now we could just use the explicit formula. 4 times 100 minus 1 equals 399. For part C, the sum of the first 100 terms, this is a partial sum. If you remember that story I told in class about Carl Friedrich Gauss, how he came up with the sum of the first 100 numbers, 1 to 100, the sum of an arithmetic, partial sum of an arithmetic sequence is first term plus last term times n over 2. So for this one, the first term of the sequence is 3. The 100th term we just found was 399. And then we're going to multiply this by 100 over 2. So that's 402 times 50, which is 20,100. 100. All right, number 27. The first row has 15 seeds. The second row has 17. Third row has 19. And so on and so on. For 20 rows. Question is how many seats are in the theater? So to go from 15 to 17 and 17 to 19 and 19 to 21, we're adding 2 every time. So since you're adding the same number, this is another arithmetic sequence. Or in this case, a series because we're adding it. And the partial sum, it's a partial sum because we're only adding the first 20 numbers, is the same as this formula here. So we're going to use the same formula. First term plus last term that we're adding, which would be the 20th term, multiplied by half of the number of terms. Now we know the first term is 15, and we know the number of terms we're adding is 20, but it wasn't very clear what the 20th term is. So you could continue the sequence out to the 20th term, just keep adding 2. Might take a little while. I'd recommend coming up with an explicit formula. So we know the common difference is 2, so it's going to be 2n, and if there were a number in front of the first term, for the 0 term, it would be 13. So the explicit formula, or nth term, is 2n plus 13. Now if you plug a 20 in for n, 20 times 2 is 40, 40 plus 13. So the 20th term equals 53. So then the sum formula, the partial sum, becomes 15 plus 53 times 20 over 2. And that's 680. Okay, number 28. Key word here is that this sequence is geometric. Remember the geometric means exponential. So the expression for the nth term, or the explicit formula, remember if it's geometric, a sub n equals the first term times the base of r and an exponent of n minus 1. So the first term obviously is 1. Now to go from 1 to negative 1/2 to positive 1/4 to negative 1/8, r, or the common ratio, is negative 1/2. So the nth term is a sub n equals first term 1 of the common ratio negative 1/2 to the power of n minus 1. Now the sixth term, we could use the formula 1 times negative 1/2 to the n minus 1 power, which is going to be 5. And that would be negative 1/32. Now for part C, find the sum of the first 10 terms. It says just set it up, do not simplify. So to set it up, this is a partial sum of a geometric sequence. So it has a different formula than the one we used above. The partial sum was first term as 1 minus r to the n over 1 minus r. So this would be 1 times 1 minus negative 1/2. Now if we're adding in the first 10 terms, the power is going to be to the 10th power over 1 minus negative 1/2. And all this has to do is set it up. Do not simplify, so we can leave it like that. Okay, last page. Okay, find the sum of the infinite series. Now this only works only if the absolute value of the common ratio is less than 1. So to go from 1 to 1/5 to 1/125 to 1 over 1/25, looks like the common ratio is 1/5. So it satisfies the condition there that the absolute value of r has to be less than 1, and it's geometric. Remember, infinite series only can be, you can only find the sum if it's geometric. And the formula is first term over 1 minus r. So the first term is 1 over 1 minus 1/5. That's 1 divided by 4/5, which is 5/4. Okay. Now it says that this sequence is geometric, or this series, and it's infinite. So we've got to figure out, first of all, what is r? And since we know it's geometric, we know there's going to be r is what's multiplying to get from term to term. So we can do the opposite. To go from 720 to 900, would be dividing. So if we took the second term, negative 720, and divided it by 900, we would sum. The sum is negative 4/5. And the absolute value of negative 4/5 is less than 1. So it fits the criteria to be able to use that formula. So the sum is equal to the first term over 1 minus the common ratio. So it's 900 divided by 1 plus 4/5, which is 9/5. That's 900 times 5/9. And that's going to be 500. Okay. Now for 31, we didn't talk about binomial theorem, so that shouldn't sound familiar. we did talk about Pascal's triangle. I'm going to draw it over here. The top row is 1, then we have a 1 and a 1. 1, 2, 1. See, the 2 is the sum of the two numbers above it. And it goes 1, and then if you add 1 and 2, you get 3. 3, 1, 4, 6, 4, 1. Now, the top row is when n equals 0. You use this row when n equals 1, n equals 2, 3, 4, and by n I mean the exponent. So here we've got an exponent of 5, which means we're going to use that row to get our coefficients when n equals 5. So this is the very last topic covered from section 8.6, expanded binomial using Pascal's triangle. So the first term is raised to the 5th power, and then that term is raised to the 0 power. And it has a coefficient of 1. That's the first term. It has, so our coefficients are going to be 1, 5, 10, 10, 5, 1. Those are going to be our coefficients. So we use the 1. Now we use a 5, and then we just keep repeating these two terms, x and -2. But this time, x is raised to the 4th power, and -2 is raised to the 1st power. Now I use my 10 coefficient, and this time x is raised to the 3rd power, -2 is raised to the 2nd power. I have another 10 coefficient for x squared, -2 cubed, 5 coefficient of x, -2 to the 4th power, and finally, coefficient of 1, x to the 0 power, -2 to the 5th power. Now, -2 to the 0 power, that's just 1. Anything to the 0 power is 1. 1 times 1 times x to the 5th is x to the 5th. And then here, -2 to the 1st power is -2, and then -2 times that 5 is -10. So it's -10 x to the 4th. And then there, -2 squared is 4, and then times that 10 is 40, so this is plus 40 x to the 3rd. Here, -2 cubed is -8 times the 10 is -80. There, -2 to the 4th power is 16, and then 16 times the 5 is 80. And then here, -2 to the 5th power is -32, x to the 0 is 1, and that's 1. So 1 times -32 is -32. Okay, this one also has a power of 5, so we're going to use the same row of Pascal's triangle, so our coefficients are going to be 1, 5, 10, 10, 5, 1. And each term is going to be 2x raised to a power and 1 raised to a power. So we have our first coefficient of 1, and the first term raised to the 5th power, the second term raised to the 0 power. Then our next coefficient 5, first term to the 4th power, then 1 to the 1st power. Now the first term 2x raised to the 3rd power, and 1 squared. Now the 2x raised to the 2nd power, and 1 to the 3rd power. And then coefficient of 5, 2x to the 1st, times 1 to the 4th. And our last term has a coefficient of 1, 2x to the 5th, 1 to the 0. Okay, so that first term, 1 to the 0 is just 1. 1 times 1 is 1. But 2x raised to the 5th power is 2x times 2x times 2x and so on. That's 32x to the 5th. Now 1 times 5 is 5. And 2x to the 4th power is 16x to the 4th. 16x to the 4th times 5 is 80x to the 4th. Now here we've got 1 times 10, which is 10. And then 2x to the 3rd power is 8x cubed. 8x cubed times 10 is 80x cubed. Here we've got a 1 times 10, which is 10. And then 2x raised to the 2nd power is 4x squared times 10 is 40x squared. Here I've got a 1 to the 4th times 5, which is 5. 5 times 2x is 10x. And it must be getting late. I had this backwards. That should be 2x to the 0 power and 1 to the 5th power. Okay, so this 10x comes from that term. And then there, 2x to the 0 power is 1. 1 times 1 is 1. And then 1 to the 5th power is 1. 1 times 1 times 1 is plus 1.